Hi, this is Paul Xun. Welcome to this short seminar. Today, we are going to introduce a new XDP-based load balancing solution for direct server returns from the backend servers that are not on the same subnet as the load balancer. So let's take a look at the notable or salient characteristics of this solution. So the direct server return is from the backend servers not on the same subnet as the load balancer. That is, they are more than one host or subnet away from where the workloads are dispatched. There are two separate XDP PBF programs running on the load balancer and backend server, respectively. The data plane is driven by cooperation between these two XDP PBF programs. Only ingress packets from clients to servers are processed, and this fits in perfectly with the XDP framework, where only packets from the receiver queues are to be processed by the XDP host. So let's move on to the network setup for the load balancing solutions. So we have two separate IP subnets. The backend server X and backend server Y are connected to the upper IP subnet. And in the meantime, the curl client and the load balancer are connected to the lower subnet. We also have a router that is connected to both IP subnet and is functioned to forward traffic between these two IP subnets. So you can see the two backend servers are not located on the same IP subnet as the load balancer. So in fact, in these particular examples, the backend servers are more than one host away from the load balancer. So we start with configuring the virtual IP address on the relevant systems in the environment. So first, we add the virtual IP address 192.168.25.10 to both the backend servers as an IP alias at the loopback interface. We also add a route on the curl client. And this route is to forward any traffic addressed to the virtual IP address through the load balancer. So after we finish the virtual IP configuration, we are in a position to build and deploy the XDP PBF programs. So first, we build the XDP PBF programs on the load balancer, and after that, we load and attach the program to the load balancer. And similarly, we also build, load, and attached another XDP PBF programs to the backend servers. And the backend servers and these two backend servers share the same XDP PBF programs. So once we deployed all the XDP PBF programs on onto the relevant systems, we are in a position to test the service traffic for our load balancer solutions. So we will issue a curled HTTP request addressed to the virtual IP address from the curl client. So first, in this path, the packet will be forwarded to the load balancer according to this particular host route rule. So the source and destination IP address of a packet in this path will be this one from the client to the virtual IP address. But once the packet arrived at the load balancer, it will be captured by the XDP PPF programs. And one of the main things done by the load balancer is to select one of the backend server to process the packet. And after that, the destination IP address will be rewritten to the selected backend server. So in this case, it will be rewritten to 172.19.04 that corresponds to backend server Y. So the IP, so the source IP and the destination IP will be written as such in this path. And in addition, the XDP PPF program will use the XDP TX action to forward the packet to the router as the next hop. So the router duly forwards the packet to the backend servers at 172.19.04. But when the packet arrived at the backend server Y, it will be captured by the XDP PPF programs deployed on the backend servers. And in this situation, the XDP PPF programs will rewrite the destination IP address back to the virtual IP address, and then use the XDP pass action to forward the packet through the native kernel stack to the service endpoint at the virtual IP address. So now the source and destination IP address will become disk. The source remained the curl client, but the destination is now modified back to the original virtual IP address. And then the packet will be processed in a usual manner at the service endpoint. And in the return path, the source IP address will become the virtual IP will become the virtual IP address, and the destination will remain the curl client. So the source and IP address match perfectly with the incoming traffic. of the curl request. So now the packets can be returned properly to the curl client. So here we conclude the round trip of the packet flow between the curl client and between the curl client and the virtual IP address. So you can see the return path will flow through the router to the curl client without stopping by the load balancer or passing through the load balancer. So next, we also take a look at some of the considerations that we have regarding our load balancing solution from the perspective of security, observability, and connection. So in the area of security, we have a couple of methods to enforce the security for our load balancer solutions. So first, for access control, we can add the Linux capabilities, cap BPF and cap net admin to only to the approved XDP PBF programs running on the load balancer and the backend servers. And the second point is that because in this particular prototype, we use the BPF tools to load and attach the XDP PBF programs. So in this regard, we will allow only Wood to execute the BPF tool. And for point number 2 and point number 3, they are more concerned about the general properties of BPF virtual machine and the BPF bytecode. So first, the BPF virtual machines is designed to run inside a sandbox within the kernel. So it means anything's happening within the virtual machine will not overspill to the kernel, and it means that they have no bearing or no interference with the activities with other activities in the kernel. And another thing is that the BPF bytecode is also safeguarded against any malpractice by the kernel verifiers. For instance, the bytecode is forbidden to access out-of-band data or memory region that is not allocated. As for observability, as you can see from our source code, we use the BPF printcade functions extensively to checkpoint or trace the running of the XDP PBF programs in real time. And if there's not enough, we can also install the third-party tool XDP dump to capture all the XDP activities at the desirable interface point. So finally, as for connection, we have already mentioned that only the ingress traffic from the clients to server will be processed at the XDP host. So more specifically, on the load balancer, the XDP programs will use the XDP TX action to transmit packet through the reception interface to the router. So this is the first part of the XDP driven traffic, and the second part of the ingress traffic is handled by the XDP PBF programs at the backend servers. So at this point, the program used the XDP pass action to pass the packet through the native network stack to the VIP service endpoint. So finally, we come to some suggested follow-up actions, and basically they are concerned about prototyping and testing. So first, you are recommended to download the source from the repository listed here. And there are detailed README instructions in that repository to walk you through the steps of setting up the environment, building and testing the prototype. So that's about it for this seminar to introduce the new XDP-based load balancing solution. And I hope you find it useful. And yes, hope you enjoyed your work with whatever technologies you use. Thank you for joining. Bye-bye.